All right, hello everyone. Meteorologist First and Weather here. It is January 5th, 2025, and we have our first major winter storm for the Mid Atlantic for this winter season. A lot to talk about here. I think if you're anywhere from Richmond to Philly to New Jersey, south of New York, you're going to be seeing accumulating snow with this system. And I think the main sort of just cutting to the punch here, the main band is going to be, or the sweet spot will be anywhere from Northern Virginia up until Philly and point south. Somewhere in there is going to see about 10, maybe 12 inches of snow, while a broad swath is going to see anywhere from 6 to 10 inches of snow for the region. So a major winter storm unfolding right now. We already have blizzard warnings up in Kansas, Missouri. Heavy snow already reported in southwestern Virginia. Snowfall in Cincinnati, Indiana, Illinois. So a big dynamic winter storm to talk about. So let's get right into it. This right here is the radar imagery from the National Weather Service here. And you can see a really healthy storm already starting to take shape for the region. You can see quite a pronounced low here, associated cold front. And we're seeing some very dynamic conditions here as well, with lots of lightning, convection taking place, really sort of kind of showing the strength of the storm, the strength of the warm conveyor belt. And that does have some implications for our region here in central and northern Virginia as to the strength of the warm air convection, how much mixing will take place, and the snowfall rates as well. And you can also see we have a pretty broad area of mixing here, as evidenced by these sort of higher radar returns and then a broader area of quite moderate snow around the storm system. And this will all gradually move to the east as we get into the late night hours tonight. So I think for central and northern Virginia, snowfall should be in the area from around, or should enter, or for first start from right around 7 p.m. to midnight. So if you're in the Richmond area, snowfall should start around 7, 8, 9 p.m. The further north you go, the later the start times will be 10, 11, 12 a.m. For those regions. Now, if we take a look here at the surface observations, take a high-res look for 20 UTC. You can see we already have some pretty widespread snowfall reports. Snow being reported in Roanoke right now, 27 degrees with a dew point of 25. So that column is saturated very quickly. Just a couple hours ago, the dew point in Roanoke was in the single digits. So you can see the snowfall is impressive enough where it's saturating the column relatively quickly. You can see we have snowfall reports down into southern Ohio, stretching back into Illinois. And this is going to be gradually moving northeast to east as we head towards the evening. I also want to point out the pretty significant dew point depressions. For example, a dew point of -5 in Northern Virginia, a temperature of 38. So while you might be thinking, hey, why are the temperatures so warm right now? Would that impact our snow? It's not. The air is very dry. We have an Arctic air mass in place. So as soon as that precipitation starts, we're going to rapidly reach the wet bulb temperature, and conditions will be very cold actually for snow. Usually in these sorts of situations, temperatures can be sometimes marginal. You have a wet, sticky snow. In this case, temperatures essentially north of I-64 will be cold enough for snow at the surface. The problem is the mixing in the mid-levels, or the warm air intrusion between 850 and 700 millibars, which is where you can see things change over to sleet, because while the temperature might be 25, 29 at the surface, it might be above freezing just a couple thousand feet up in the air. And that causes sleet, freezing rain, and all the icy issues that always result. And the reason for that is that because this is primarily a warm air advection driven storm. So we have a short wave, we have that low moving to the east, and as a result of that, you have very cold air entrenched at the surface, and then warm Gulf of Mexico air riding on top, right? So water or dry air is more dense. You have less dense, moist air rising over the top. You have isentropic upglide as that happens. And then that creates lift, and that creates precipitation. And that's exactly the setup we're seeing here. We take a look at the satellite imagery. We can already see we have an expansive area of cloud cover. This system has really just exploded over the past few hours. You can also see a pretty pronounced dry slot over the eastern portions of Texas, southwest Arkansas, and that will also play a pretty significant role in snowfall amounts, because as the system moves to the east, this dry slot is going to also move to the east, and that will lead to a lightning or even a complete shutdown in snowfall totals or snow rates for a certain period of time in certain regions. And I think that will lead to sort of a lull in the main snow around Monday afternoon before we see a return to some lighter to moderate snow on the backside of the system for Monday evening into very early Tuesday morning. This right here shows the water vapor imagery. So again, you can see a pretty healthy looking storm. You can see the dry slot here, dry air being put in all the way from Canada. So that's wrapping into the system. You also have very healthy convection taking place, feeding in moisture and instability and helping to create these very heavy snowfall rates. Excuse me, just north of the low, and also causing the sleet and freezing rain. You can see also we're already seeing a moistening of the profile in western and eastern Virginia with those high level cirrus clouds now passing over. One thing to note is that in recent hours we have seen some pretty heavy snow actually moving into southwest Virginia a bit earlier than expected. What that says for our event overall remains to be seen, but I think overall we have a pretty significant winter storm now on the way. Another thing I want to kind of point your attention to is what's keeping the storm from moving northeast. We already have a neutrally tilted trough like this, and so typically this would mean you would be seeing a rain event for large portions of I-95 in the Mid-Atlantic as that low would then track inland. However, what we're actually seeing is we have a piece of energy, a strung out piece of vorticity moving southwestward, courtesy of a strong 50-50 low from a previous system we had a couple of days ago, and that's acting as confluence, essentially creating high pressure here, forcing the system southward and keeping the cold air firmly entrenched into the mid-Atlantic here. And that's what's keeping this a wintry system and not a rainy system for the lower mid-Atlantic. Finally, here we can take a look at the COD imagery satellite. This shows visible satellite, lightning, and temperatures. And I want to point your attention to the pretty deep instability and convection we're seeing here. All these stars indicate lightning. And I think it's not out of the question that some areas do in fact see thunder snow in Virginia as the system moves to the east, as we have really intense warm air advection and convection taking place. So that's also something to monitor. Now, if we take a look here at the overall synoptic setup, what is causing this winter storm? So the first thing that really kind of comes to mind here is you have this vigorous trough right here, this shortwave trough. Let me increase the size of the pen very quickly. So you have this trough right here, this piece of energy. It's pretty broad right now, but you also have an upper level low, and this is causing cyclonic vorticity advection. You have impressive Gulf of Mexico moisture now being advected northward. That isentropically upglides over the cold, dry Arctic air, and that creates precipitation. And that's why we're seeing all this precipitation now breaking out over the past 24 hours in the Midwest, in the Ohio Valley, and that will only move eastward. You'll also notice that the feature I pointed out earlier, which is the confluence right here. So you have wind going this way, you have wind going like this. That creates confluence here, sinking air, keeping the system moving along a due east path and keeping cold air firmly entrenched here. And as we go through time, you can see that that lobe of energy here starts to swing down. It reinforces some confluence and makes the system go south. And then as that short wave moves to the east, we have that precipitation field now moving to the east as well. This is now 9 p.m. Eastern time over for the snowstorm, and you can see we have our vortex centered right over central Virginia, and that would indicate the greatest lift, greatest snow to be right around right here. So the greatest lift, greatest snow would be right in this region right here, a bit to the north. So this NAM run right here indicates the heaviest banding, the heaviest precip rates to be in northern Virginia, Maryland, and also in southern New Jersey. Now, as that system moves off the coast, we have an interesting feature that might develop, which is an inverted trough. As this low moves off the coast, it taps into the warm ocean waters. That creates a thermal gradient, and you have an intensifying low, and that might create an inverted trough, which might create a second sort of lighter wave of snow on the backside of the system. The snow will be fluffier, higher ratio snow, so instead of 10 to 1, it might be 15 to 1, with cold temperatures, a deep DGZ or dendritic growth layer, and that might also pile on a couple more inches of snow in areas that have already been hard hit. So as this vortex here moves off the coast, you have your inverted trough right here. So you have your dip, you get lifting, and you get another area of snow on the backside of the system here to end the storm. Now let's take a look at the NAM 3 kilometer 850 hectopascal frontogenesis. So this kind of gives us a good idea of where the greatest lift might be, where there's going to be a lot of warm air advection. And typically when looking at 850 millibar frontogenesis, the best snowfall bands and rates are located just to the north. So in this case right here, your greatest frontogenesis is in this band here. So that would indicate your greatest snowfall rates would be right around here. All right, and so that's the NAM showing a bullseye of snow from Northern Virginia up until southern Maryland, far southern New Jersey, etc. And as we go through time here, you can see that the NAM is very impressive on the frontogenesis. It has it pretty strong here as the system approaches, weakens a bit, but you can see here 60-knot winds or even more, pumping in warmer air from the Gulf of Mexico, and that's why we have so much mixing with the system. So if you look at the actual radar rain frozen, you can see we have a broad area of mixing precip all over central Virginia. And that's what's going to really cut down on snowfall totals if you're south and along of I-64. You have very cold at the surface, but the mixing from warm air loft is going to quickly change things over to sleet, freezing rain, maybe even plain old rain for a bit here, while things stay relatively snowy to about 50 to 100 miles to your north. We can also take a look at a different model here. This is the RGEM Canadian model. It's a very good model for snowstorms. It does have a bit of a cold bias, but you can see here it is pretty similar to the NAM for our upcoming system. But one thing you might notice is that the greatest area of frontogenesis is just a few miles, about 20 to 50 miles to your south, and hence it has the greatest snowfall banding right over central and southern parts of northern Virginia here. So this is the NAM on top, this is the RGEM below. So very small differences have big impacts on where the snowfall maxima will be. Now, looking at the data, I think I do place more trust on a more northern extent for the snowfall maxima. I don't think areas south and along of I-64 will be anywhere close to seeing the snowfall maxima. Maybe Fredericksburg around there might be close to it, but right now I do favor the NAM solution to see a snowfall maxima right around DC, pointing to the north, so in this black circle right here. I think these areas are the most favored to see maybe 8, 9, 10 inches of snow, and a couple areas wouldn't surprise me if they see a foot of snow with this system. Areas to the south, areas to the north, a broader 5 to 8 inches, and then a quick cutoff here as you go to the north, and a quick cutoff as you go to the south because of mixing as well. Now we can take a look at some sample soundings, just to give you an idea of what's going on dynamically with this system. So this right here is the NAM sounding for 10Z on Monday. So early morning Monday, this is an area average sounding for Northern Virginia. You can see we have a relatively impressive sounding here. We have deep saturated profiles. The DGZ is a bit more shallow and a little less saturated than ideal. So even though we have very cold temperatures at the surface, that doesn't necessarily mean we're going to see very high snowfall ratios. This would indicate, maybe 12 or 13 to 1, maybe 11 to 1. Ideally, you would like to see a more saturated DGZ and a deeper DGZ to allow for more optimal snowfall growth. If we take a look at the same time, we look at areas like Richmond, and this kind of goes to show why we have the issues with the mixing. We can see that we have temperatures at the surface right around freezing, but as you go aloft, temperatures cross that boundary and go to around 32, 33 degrees, and that creates just enough melting to see sleet instead of snowfall. And as you go even further south, the issue becomes even worse, more pronounced. You have a broader area of temperatures above freezing, and that creates plain old freezing rain. Now, if you look here, if we take a look at a cross-sectional sounding, so if we go right through here, look at omega frontogenesis, you'll notice that the biggest lift is in this sweet spot. Not exactly at B, not exactly at A, but right in the middle. And so that leads me to believe, and historically speaking, you want to be in a sweet spot zone where the mixing line is about 20 to 30 miles just to your south, and areas just to the north of that mixing line by 20 miles or so typically see the greatest snowfall rates, where you have the most warm air advection, the most convection, the most lift in the atmosphere, but you're also cold enough for snow. And that's where typically the snowfall maxima will take place. And you can see that nicely here with the NAM sounding showing the greatest lift right in the middle. So if we go and draw that out here, that would be right around here. All right, and so that's what the sounding is showing. This also shows up pretty nicely when looking at the snowband parameter using the HREF and the HER model. This kind of gets to show you where there's the best chance to see, significant snowfall rates. Half an inch an hour, 1 inch an hour, 2 inch an hour snowfall rates. And as we go through time here, there's a robust signature to see 1 to 2 inch per hour snowfall rates right over the Northern Virginia area. Notice how there's not really much showing up for Central Virginia or areas in Philly, but right in that sweet spot between Fredericksburg and Baltimore, I think is where we have the greatest chance to see again the snowfall maxima. And now as we take a look at the overall radar picture, typically you don't want to become too reliant on just watching the blind model output of precipitation reflectivity, but this can give you a good idea of what exactly is going on. So the NAM here shows the first wave of snowfall reaching the Richmond Metro, Central Virginia, right around 9 p.m. Keep in mind that some of this will evaporate first. A lot of it will be verdure, so it might take an hour or so for the profile or the atmospheric profile to become saturated. Once that happens, snowfall will start to fall. It might be moderate to heavy at times before a quick transition to sleet and freezing rain for areas along and south of I-64. Moderate to heavy snowfall reaches the DC metro area by around midnight to just after that. And then we have periods of snow continuing for Northern Virginia up until right around 8 or 9 a.m. on Monday before we see a lightning of rain and the dreaded dry slot moving through, as you can see nicely here. That's a dry slot cutting down precip, cutting down snowfall rates. And then you can see in Central Virginia, the NAM is showing downright rain and freezing rain. I think this might be a bit overdone, but it goes to show you that mixing will be a significant issue for areas south and along I-64. So right here and point south, I think icing, you might see 1/10 of an inch to maybe even 2/10 of an inch of ice, which will create big issues on the roadways. So while you might be seeing less snowfall in southern areas of Virginia, the road impacts might be just as bad, if not worse, because on top of the snow, you're going to have a layer of ice, creating an ice skating rink for all the roadways, and that's going to be something to watch as well. As we go through time here, the NAM, you have that break in precipitation, and then you have that inverted trough signature starting to take shape here. As you can see like this, that creates additional lift, higher, fluffier snow on the backside, and it wouldn't surprise me if this feature right here overperforms just a little bit. History says that with these inverted troughs, they're unpredictable. They can have heavier than expected snowfall rates, and snowfall ratios will be very high as well. And that might create, another 1 to maybe even 4 inches in spots of snowfall, adding to the already pretty impressive totals here. And so now if we take a look at the national blend of models, this is a great tool. So instead of looking at each model individually and kind of guessing and checking, this is a mean of all the models. It's a skill score weighted mean of all the snowfall output, and this can give you a really good idea of snowfall in different regions. And so you can see here it has a solid right around 4 to 8 or 6 to 10 inches of snow in the DC area, Northern Virginia. Keep in mind though that I think this southern extent of snowfall is pretty heavily overdone. I don't think it's picking up on the mixing that well. So if you're right around south of Fredericksburg in these areas right here, I think the snowfall output is quite a bit overdone. So in these areas right here, I think it's more of a 2 to 5 and then a 1 to 3 for the city of Richmond. And a much bigger concern of icing as well. I do like what it's saying for Northern Virginia, Maryland as well. I think your sweet spot's going to be right around this region right here. This right here is the SREF, which is another series of models which use different convective parameterization schemes, different model physics to kind of get a better ensemble idea of snowfall. And I like this as well. It shows a nice little bullseye over Northern Virginia, 11 inches of mean snow. That might be a bit overdone, but it gives you a good idea of where the exact maximum will be. I also really like what it's showing for Central Virginia with 1 to 3 over Richmond, 2 to 5 just north of that, and then a pretty quick transition to heavier banding of snow in Northern Virginia, Maryland, New Jersey, and also very far southeastern parts of Pennsylvania. So with that, let's show my snowfall forecast map for January 5th through January 6th. You can see here for the city of Richmond, Varina County, Henrico County, Chesterfield, 1 to 3 inches of snow. As you get north into the west end of Henrico, Goochland, Hanover County, Louisa County, Charlottesville, I think 2 to 5 inches of snow is a good bet. North of that, this includes Fredericksburg. I think 5 to 8 inches of snow is a good bet here. This will be a good system, a good plowable snow for you. 5 to 8 inches of snow for areas just north of Baltimore. I think Baltimore will squeeze into the 6 to 10 inches of snow, and then 2 to 5 inches of snow in southern New Jersey and northeastern Maryland here. And then finally for DC, Chantilly, Fairfax County, Arlington, Loudoun County, all these areas right here, the DC city area, 6 to 10 inches of snow, and plus I think some areas in this area will see 11, maybe even 12 inches of snow, but the vast majority of you will see between 6 and 10 inches of snow with this system. And also I want to point out really quickly here where I think icing will be the biggest concern. Let me get my highlighter, paint it in pink. So anywhere south of this line, I think icing will be a very big concern with the system. So please be careful. If you don't need to, please don't go out on the roadways. They are going to be an absolute mess starting from tonight all the way till Tuesday night, maybe even Wednesday morning. We have very cold air on the way after the system. And so that will ensure the snowfall stays for a very long time after the snowfall ends. If we look at the GFS forecast temperature anomaly, we can see that we have very cold air in place for a good deal of time, and that's also something to be mindful of. So with that, that's my video. I hope you guys enjoyed. Please stay safe. If you're hoping for snow, I wish you good luck. If you don't want snow, hopefully you don't get too much. That's my forecast for now. Again, 6 to 10 in DC, Northern Virginia, 1 to 3 for Richmond, 2 to 5 for areas just north. All right, stay safe.